Hi guys, this is MedPewterberry and welcome to my channel. In today's video, we'll be discussing our Darrow-Yannet diagrams and we'll go through some cases. So let's start with what the normal looks like. And this is the normal diagram. We have our ECF or extracellular fluid on the right. We have our intracellular fluid or ICF on the left. Our y-axis is osmolality. Our x-axis is volume. Okay. So there's going to be two rules that we're going to follow to go through these diagrams. The first rule is, how does the osmolality and the volume change in ECF? Okay, so we're going to first look at what's going on in the ECF. Are we adding or losing mostly water, hypotonic fluid? Are we adding or losing mostly salt, hypertonic fluid? Are we adding or losing both water and salt, something more isotonic? And then the second question we're going to ask ourselves is, where will the water go from the ICF? Okay, so this is going to make more sense when we actually go through the cases, but really the second thing we're going to see is, where will the water go? Will it leave the ICF or will it enter, or more water will get into the ICF? Okay, so just stick with these two rules and then let's work through our cases. So our first case is diarrhea or loss of whole blood. When someone has diarrhea or someone's losing whole blood, you're essentially losing a lot of isotonic fluid from your ECF. So this is really the easy case, because if it's isotonic fluid loss, will your y-axis change? Will your osmolality change? It will not. So you're not going to go up, you're not going to go down, you're just going to stay at the same osmolality because it's isotonic fluid loss. And you're simply going to move left on the volume, on the x-axis, since you're losing fluid. Okay, so stay on the same osmolality, just move left, and that's it. And because there is no change in osmolality, there will be no movement of water into or out of the intracellular fluid. So you don't really have to do your step 2 for this one. Okay, so this is what this new diagram is going to look like. So another easy case that we can do is addition of whole blood or giving someone IV fluids. That's an addition of isotonic fluid, right? So in terms of your ECF, your osmolality stays the same. You don't go up, you don't go down. You just expand your volume. So you move to the right and the volume gets bigger. And again, because this is isotonic fluid gain, there will be no changes in osmolality on either side, so the water will just stay where it is. It's not going to move. And that's what our new diagram is going to look like. So these are like the easy cases, but let's get into the more complicated cases. Let's do this case, okay? Excessive salt intake. So someone's taking in a lot of salt, or we're giving someone a sodium bicarb drip. Okay, so what we're doing is we're adding hypertonic fluid to the ECF. So we're adding a lot of salty fluid to the ECF, right? So what do you think is going to happen to our osmolality? It's going to go up because we just added a lot of hypertonic fluid. And we added, so the volume is going to expand, right? Because we gave them a sodium bicarb like solution, or so something was added, so the volume is going to go up. So that's our change in the ECF. Now, coming to our second question. Where will the water move from the ICF? What has happened in our ECF that our osmolality has gone up? So it's higher salt on this side of the graph. Water always moves towards higher salt, right? So water from the ICF will want to move towards the ECF where there's higher salt now. So you see our second question, our second arrow will be water moving from the ICF to the ECF because there's higher salt in the ECF now, okay? So your new Darrow-Yannet diagram will look something like this. You can see water left the ICF, so our volume of the ICF shrunk, right? And instead we pushed all of that volume towards the ECF, okay? So case 4, these cases get easier as you go through them and once you practice them out. So I'd really highly recommend, just practicing them out with your study partner, or just, quiz each other or something like that. Or just draw it out on your whiteboard, it helps. Okay, so case 4, someone's sweating, someone's going into DKA, and alcohol, because when you drink a lot, you have to pee a lot. Insensible water loss, coma. So anytime you're peeing too much, right? Something like diabetes insipidus almost, when you're losing a lot of just free water, you're polyuric, right? Polyuria. So you're losing a lot of hypotonic fluid from the ECF. So what's going on in the ECF? All the water is being lost. However, it's mostly water that you're losing. So what's going on to the salt here? It's going to go up. So it's going to get more and more concentrated. So salt will be left behind when you lose all the water. It's going to concentrate the ECF even more. So our osmolality this time go up. And you're losing fluid, so your volume will shrink. It's going to be higher concentration, but with a shrunken volume. Okay? So again, higher salt on the ECF side. Ask yourself the second question, how will water move from the ICF? Well, again, it's going to go from low salt to high salt. Okay? So our new Darrow-Yannet diagram will look like, or should look like this. Okay? Case 5. This is the absolute opposite of case 4. So here what's going on is you are not peeing enough. You are not making enough pee. You're holding on to all the water that you're drinking, okay? So that's SIADH, or syndrome of inappropriate ADH secretion, where you have too much ADH and it's just constantly reabsorbing the water back into the body. Or just someone's just compulsively drinking a lot of water. Or there is some right heart failure and you're holding on to a lot of that fluid. So what's going on here, okay? You are essentially adding, or this, it's almost like a fluid overload, okay? A lot of a water overload. So what happens when there's a lot of hypotonic fluid in the ECF, or addition of hypotonic fluid? That's going to really dilute the ECF. You're going to have a very dilute ECF. So the concentration of the ECF will go down and it will expand because it's holding a lot of water, but also it's diluting the osmolality or the solutes, so the osmolality goes down. So this is how you're moving on your ECF. In terms of your ICF, how's the water going to move? Now, there's lower salt here, there's higher salt on the ICF side. So this time it's going to switch. Water will move from low salt, ECF, to a higher salt, ICF. Okay? So this is what your new Darrow-Yannet diagram is going to look like. Okay? And let's just go through our last case. This is our case of loop diuretics, adrenal insufficiency, or Addison's disease. And what really goes on in all of these diseases, or maybe with our loop diuretics, which are a type of diuretic drugs, is we're losing a lot of salt. It's called salt wasting, okay? We're losing a lot of salt from the ECF, and mostly salt. Yes, we're also losing some fluid and some water, but it's heavy on the salt aspect, right? So what's going to happen is that your osmolality will go down because you're losing a lot of sodium. So osmolality goes down, so sodium loss, so you come down on the y-axis, and then you're also losing fluid, so you're going to also go towards the left in terms of volume. So it's a shrinking volume, but mostly losing salt. And then the second question you ask yourself is, how will the water move to the ICF? Now again, there's lower salt here. See, the osmolality came down. So low salt here, water will move from low salt to higher salt. It's going to move from the ECF to the ICF. And this is what your new Darrow-Yannet diagram is going to look like. So that's it. So that's all. I know this was a very quick video, but those are all your cases that they could possibly ask you in the question. Just practice them out and follow the rules. It makes it really easy to kind of, go through these diagrams. Okay, thank you. Good luck.